You ever just look up at the night sky and wonder how it all got here? We're not talking about some simple bedtime story. We're talking about the real story, the 4.6 billion year epic. So let's just dive right in. Because the story of our home, well, it's one of the greatest and honestly most violent sagas ever told. I mean, it's the big one, right? The ultimate question. You look out there, you see the sun, the planets, all the moons, and it all just feels so permanent, so orderly, like it was always meant to be this way. But how did this huge, complicated system actually get here? We all kind of got a version of this in school, right? But let me tell you, the real story is something else entirely. Yeah, so you can just forget those neat little diagrams from your science textbook. You know, the ones with all the planets forming in these perfect, tidy circles. The real story, the one that the latest science is telling us from looking at actual cosmic fossils, it's a completely different tale. It's a story of just brutal collisions, giant planets going rogue, and a whole series of cosmic close calls that, honestly, make the fact that we're even here to talk about it seem like a total miracle.
Okay, so where does our story begin? Well, like a lot of great stories, it starts with a cloud. But this isn't just any cloud. We're talking about a gigantic, swirling cloud of gas and dust out in space. And under its own incredible gravity, it just started to collapse in on itself. Right at the center, boom, our sun ignites. And all the leftover stuff, it flattened out into this huge spinning disk. And this stage, it has a very cool, very specific name. So this spinning platter, it's called a protoplanetary disk. And you really got to think of it like a cosmic nursery. Or maybe a giant factory floor. It's the place where literally everything was put together, from the tiniest little asteroid all the way up to the massive Jupiter. Everything that makes up our solar system, including us, by the way, got its start right here, in this incredible swirling disk of dust and gas. So, you're probably wondering, how on earth do we know any of this? I mean, it was billions of years ago. Well, it's because we have actual time capsules. The meteorites that fall to Earth, they're the oldest things we can physically touch. They are direct leftovers from that very first disk. They're basically cosmic fossils. And because of them, we can put together a surprisingly precise timeline of how the solar system was born. And when you look at this timeline, what's just mind-blowing is how fast it all happened. Okay, so at year zero, the very first solids, these things called CAIs for short, they condense out of the hot gas. Fine. But then, get this, in less than 500,000 years, which is nothing, a blink of an eye in cosmic time, the very first asteroids, or at least their parent bodies, were already forming. And by 1 to 2 million years in, we already had the first real building blocks of planets, these things called planetesimals, and they were already forming cores and mantles? This was not a slow, gentle process. This was a frantic, absolutely lightning-fast construction project. I mean, this really puts it all into perspective, doesn't it? Think about it. The first asteroids, built in under 2 million years, quick and dirty. But a whole planet like Earth, a complex world, oh, that took way longer. We're talking 38 to 120 million years of just constant violent collisions and mergers. So building the small stuff was fast, but building a world, that was a long, brutal slugfest. Which, raises a pretty big question. How in the world do you go from those tiny first asteroids to a full-blown planet? And this, right here, is where the story kind of hits a massive brick wall. See, it's one thing to make a small rock, but it's a completely different ballgame to build something the size of, say, Jupiter. For the longest time, the physics just didn't add up. It looked like it should be totally impossible because of these huge roadblocks, these barriers to growth. Okay, so check out this planetary assembly line. It's got some serious problems. Step 1 is easy enough. Tiny dust and ice particles stick together, they form pebbles. No problem. But then you hit problem number 1, the bouncing barrier. Once these things get to be about 1 millimeter big, they stop sticking. They just bounce off each other, like tiny little billiard balls. Dead end. But let's say you magically get past that. Well, now you've got an even worse problem, the radial drift barrier. Boulders about 1 meter wide start to feel drag from the gas in the disk, and it slows them down. And what happens? They spiral right into the sun in just a few hundred years. It's a cosmic death sentence. Game over. So, how did anything survive this? Well, the leading theory is turbulence. These swirling pockets of gas would have gathered up tons of particles, packed them in super tight, so tight that their own gravity suddenly took over, and poof, they'd collapse directly into the first planetesimals, basically skipping those 2 deadly steps in the middle. Pretty clever, right?
All right, so for a long time, the picture we had in our heads was that our sun formed all by itself, in some quiet, lonely corner of the galaxy. Well, it turns out that picture is completely, totally wrong. The evidence is just overwhelming now. Our solar system wasn't born in isolation. It was born right in the middle of a chaotic, crowded, and frankly, very dangerous party.
Get this. Our sun was probably born in a huge star cluster with more than 2,000 other stars. 2,000 siblings. Just try to imagine that. Our tiny, fragile, developing solar system stuck in the middle of a cosmic mosh pit, with other stars, some of them huge and violent, flying by dangerously close.
And again, how do we know this? It's like being a detective. The clues are written right into the solar system itself. For instance, we find certain radioactive elements in meteorites that could only have come from a nearby supernova, an exploding star. And the very edge of our solar system, it looks like it was just sheared off, probably by another star that flew by too close. You add that to the really strange orbits of things way out past Neptune, and even the fact that our sun is slightly tilted, all the evidence points to one thing: a violent, crowded childhood.
So, okay, eventually our solar system got kicked out of that dangerous star cluster and was on its own. So things calmed down, right? Nope, not even close. In fact, the most violent part of the whole story was just about to begin. And the culprits? Our very own giant planets.
See, the modern picture is that the giant planets, Jupiter, Saturn, Uranus, and Neptune, they didn't form where we see them today. They were actually born way closer together in this really tight, compact formation. But as they interacted with all the leftover debris, their orbits started to change. They started to wander. And this planetary migration eventually set off a system-wide gravitational disaster, a complete cataclysm.
And if you want proof of this violence, you don't have to look very far. It's literally carved into the face of the moon. You know those giant dark patches on the moon? The huge craters? Well, it turns out they all formed in this incredibly short, brutal time frame, about 800 million years after everything started. This was the late heavy bombardment. It was basically a cosmic pinball game, with the giant planets flinging a massive storm of asteroids and comets right at us, battering the Earth, the Moon, Mars, everything in the inner solar system.
So, after all that, after a chaotic birth and a super violent youth, our solar system finally settled down. It entered this long, stable middle age that we're living in now. But this isn't the end of the story. This period of calm, it will end. The final act of this whole 4.6 billion year saga, well, it's already been written. It's just physics.
Here's what's going to happen. In about 6 billion years, our sun is going to run out of hydrogen fuel. It's going to swell up into a red giant. Mercury and Venus, they're toast, completely swallowed. And Earth? Well, our fate really hangs in the balance. We are right on the edge. The sun might just engulf us, or it might push us away into a much more distant, frozen orbit. We don't know for sure. The outer planets, Mars and beyond, they'll survive, but they'll get pushed way out into the cold and the dark, orbiting what's left of our sun, a tiny, faint star called a white dwarf.
And that brings us right back to the beginning, doesn't it? From a simple collapsing cloud through all those impossible barriers, a crazy crowded stellar nursery, and a planetary demolition derby. Here we are. So what's the big takeaway? After hearing this whole chaotic story, what do you think? Is our solar system with its stable, life-bearing planet a masterpiece of physics, something that was bound to happen? Or are we just the improbable survivors, the ones who got lucky in a cosmic story that's really all about chaos, violence, and maybe just sheer dumb luck?